Hello, my name is Pocsatko. I'm a senior consultant with Slalom right here in Columbus, and this is how to test your cloud code confidently. So the agenda for today, we'll start off with a brief introduction to who I am. We'll go into a technical background about the problem we're trying to solve. Then we'll go into what that problem is before moving into the stubber, the solution to the problem, and then ending things off with a live demo. So now let's do my introduction. Again, my name is Pocsatko. I'm a cloud senior consultant with Slalom right here in Columbus. I've been with Slalom for just over 2 years, and I focus primarily in AWS Cloud. Now, I live in Columbus, Ohio, and I'm originally from Pittsburgh, Pennsylvania. I'm an Ohio State grad of the class of 2019 with a degree in computer science and engineering. I've got 5 years experience with AWS and 9 years experience on and off with Python through my college and professional career. So now let's get into the technical background on the problem we're trying to solve today. AWS is one of the largest cloud providers around the world, offering hundreds of different services and products that devs and engineers can leverage to build and host their applications. Cloud-native applications will regularly utilize multiple AWS services. An example of this would be an API that uses API Gateway with a Lambda function to upload to an S3 bucket or update a Dynamo table. Building these apps with Python is made possible with the Boto3 SDK that is maintained by AWS. This SDK serves as a client to invoke other AWS services from your code. So now that we have an understanding of the technical background, what's the problem that we're facing? That problem is, how do you run unit tests on code that interacts with other cloud resources without actually affecting those resources? We can't guarantee the state of any other resource that's in the cloud at the time we run our unit tests, and we may want to run these unit tests locally but are unable to access the cloud environment while running those tests. And running these tests with the possibility of actually invoking real cloud resources introduces the possibility of a unit test failure due to networking or security reasons. And it is very important to test and validate your AWS networking security, but unit tests should be focusing on the functionality of the code itself. So now that we understand the problem at hand, what's the solution? That would be the stubber. The stubber is a class of Boto core that allows you to stub requests made in your code while running unit tests to allow you to test without actually interacting with any deployed cloud resources. And as a note, Boto core is the low-level interface to many AWS resources, and it's the backbone of the AWS CLI and also the Boto3 library that we're using in our code. Now, what does stubbing actually mean, though? Stubbing a method means to use one piece of code to stand in for another piece of code while executing. So what this means is, using the stubber, we are able to intercept code while running our unit tests and have the results replaced with whatever our code says instead. Now, this is not to be confused with mocking in unit tests, but mocking is a separate topic that we're not going to go into today, and I highly recommend you look into it if you're more interested. But knowing that, why should we stub? What's the point of replacing code with other code while running a unit test? It sounds like that's not actually testing our code. Well, using the stubber, we're able to test that all the Boto3 methods we're calling in our code are called correctly. This means called with proper arguments, we're validating that these calls actually happen, and we're validating that calls can happen in the correct order. Additionally, we can also validate that we're getting the expected exceptions raised when things are supposed to go wrong and be caught. The stubber also allows us to guarantee the result that every method will return, allowing for every single unit test to operate with the same response every time they are ran. This allows for consistency of runs and ease of your assertions. You no longer have to worry about what happened to the Dynamo table when running a unit test if you're always going to get the same thing. And this allows us, especially when replacing Boto3 method calls with the stubber, we don't have to be testing AWS's code for them. We can just get the results that we are expected to get based on their API documentation, allowing us to focus on the code that we're writing. Now let's get into a brief demo and we can show how the stubber works. For this demo, we'll be starting off with the basic AWS SAM CLI use case example for Python 3.9. This includes a Python Lambda function called hello world in this app.py file that as of now just returns a 200 and is invoked via an API gateway deployed through the CloudFormation template here. However, today we're going to be focusing more on the unit tests, so we'll start off by looking at our test handler here. We have a mock API event that we'll be using as part of this test, and we'll start off by running this test. We will run PyTest on this, and you'll see that we get a pass. However, if we go back to our app, and then we add in the DynamoDB call and try to run that test again, we get a failure because it's trying to find my AWS credentials to locate this resource in the cloud. However, since I don't have my credentials file activated right now, it's not able to find that. So this unit test fails. Now, how do we add in the stubber code? So we'll come back here to the test handler. I'll make the screen a little bigger, and I'm going to expand out this commented box here. So the first thing that's required is setting up a Boto3 client. What a Boto3 client is basically just an object that is used as a client to interact with the AWS resource in question. In this case, it's DynamoDB. Next, we create our stubber. For this use case, we'll be using a with statement to keep the stubber and all of our calls encapsulated instead of having to activate our stubber. So we're creating this stubber using our Dynamo object, and we're calling it stub. With there, we then can add a response to our stubber. What the add response method does is it will look for this method being called in our app.py or whatever we're calling. So we've got app.py here, and we're calling dynamo get item. So we're adding a response where wherever stubber, after we're going to replace that client with our fake client, it'll be looking for whenever it calls get items, it'll be returning this exact format as its response. The second argument is always the response value that our fake method will return. And then this is the input it's expecting. So you'll see back here, we're looking for this input of demo ID as an ID, and the table name is fake table. Both of those line up. So now we can then replace the call for our actual Boto3 client in the code. So now whenever we make that client in app.py, it's replaced with the one we made here that has the stubber attached to it. We can then uncomment the regular unit code and get rid of the duplicate code here. So you'll see that we are just getting the response from the application handler, loading the response, and then just asserting that everything's correct. So now we've got the stubber in place. Let's run PyTest again. And we get a passing job because we've replaced what it's showing with what we're showing. And if we run this with additional prints on, you can see that we're printing out what we're getting. And you'll see that it lines up exactly with what the stubber defines in its method that we wrote is going to return for us. Now, we can't just define whatever we want as the response value for get item. For any stubbed response, it has to match the specification as defined in the Boto3 API specification. So we've got this item here, which is the top level key for any dictionary returned by the get item call. However, if we change this to items and try to run our tests again, it fails because unknown parameter and input items. It must be either item or consumed capacity at that level. So we can't have outputs that would potentially mismatch the definition provided by Amazon, which is another thing that makes stubbing very valuable to ensure that we're getting and working with responses that we are going to be guaranteed to get in the format of. Additionally, the input to our function that we're stubbing needs to match what's coming from the input in our app.py file. So right now we're both expecting this table name of fake table, a key which is a dictionary of ID, and then S and then demo ID. If we come over here and change this to demo IDs and try to rerun that test, you'll see that we get a failure because these do not match. It's expecting demo IDs but received demo ID. So this allows us to validate that we are going to be giving the functions from Boto3 exactly what we expect to be giving them. Now, that was a fairly simple example with only one Boto3 call being made from our app.py file. But what happens when we start having more calls? Let's go into our app.py file and we'll add in this DynamoDB describe table call to describe information about our fake table. If we run our test again though, you'll see that we get an unstubbed response error. So you're seeing here in our test handler that we're intercepting and replacing the expected client with our fake client that is used by the stubber, but it doesn't have a stub for that additional method call, so it fails our test. This is a good thing so that we can validate that all of our calls are actually being made and being made in the correct order. So now let's add in the stub for this new function that we've added. I'll come in here, I've already pre-written this, we'll paste. So again, we're doing stub.addResponse. We're using describe table because that's the method that we're calling. The expected response we have is this table with table name. The output for DynamoDB describe table is actually much longer than this, but one nice thing about the stubber is that you do not need to define all of the optional arguments and other things for a response. You only need to define exactly what is required for both the input and the expected output. So we're just doing the table name, and the expected input matches up with our app.py of this fake table. So we can go ahead and run our test again. You'll see that we get passed with the same print statement from earlier. So now that we know how to deal with multiple API calls, how do we deal with multiple Boto3 clients? Because currently we're only making a stubber for our Dynamo client. So if we go back to our app.py, we come down here. I've created now a Lambda client. I'm using Lambda as the name since Lambda is a keyword in Python. Then we're calling Lambda get function about our fake function here. If we run our tests, see that DynamoDB has no object attribute get function. That's because since we've only got one stubber, and even though we're making a second client here, when we're making this second client, we've already told our test to replace this Boto3 client with this Dynamo value every time. So it thinks that that's a DynamoDB client. We don't want this, so we'll need to make another stubber and update our patch. Through the power of conference magic, I've updated this test to have our new stubber. You'll see first, we're creating a client, much like we do in both our app.py and for our DynamoDB here. We're then adding to our with statement here this stubber lambda as lstubber. This will give us another stubber that we can use within this with block. And we'll scroll down a little bit, and you'll see that we're stubbing this get function call here. We're doing the same sort of deal here where we're not including all of the possible outputs from a get function call, but we're doing what we're expecting and what matters for our test. So we're verifying here that we're using the same input from the app.py fake function. Then we're expecting this fake function back. Now, how do we deal with the mocker patching the Boto3 client call? Well, Magic Mock, a feature of PyTest, will allow you to use this side effect here and give you an order for which this call will return values. So the first time we call Boto3 client, it will return Dynamo, and the second time it will return our Lambda objects, which we both have stubbers for. So now if we go to run our test again, you'll see we get a passing value. The last thing I'd like to talk to you about today is the importance of the assert no pending responses method within the stubber object. So if we come to our unit test here, you'll see that I've added a couple of new responses, one for describe table for fake table 2 and fake table 3. However, back in our app.py file, we don't actually make those calls. So let's go ahead and run that unit test and see what happens. And it passes because we're not making those calls, so who cares? And you might be thinking to yourself, why bother? What does it matter that these extra responses are here? Think about if your code has branches in it, and you might be expecting a certain function to be called as your code goes down a certain branch. If this passed and your code wasn't called, then you might not even know that there was a failure afoot. So that's where assert no pending responses comes in. If you come down here, you can make some room, and we will do stub dot assert no pending responses, and the same for our other stubber, lstubber, assert no pending responses. Now, if we run that test again, you'll see we get a failure because there's responses remaining in the queue, and this would tell us that if a function we were expecting to be called wasn't called, that it was not being called, and we would be able to go debug what was happening that it was being avoided. So this wraps up what I have time for today, talking about the stubber and Boto3. I hope you enjoyed this presentation. There's many more things the stubber can do, such as defining assertions and exceptions that you should be expecting, and it is a very helpful tool for locally running unit tests on your cloud code. I hope you have a great rest of your PyOhio, and enjoy the day.